Hi everyone, and welcome to OpenMined AMA. Ask me anything. OpenMined is an open source community focused on making the world more privacy preserving. In this AMA interview, you'll have the opportunity to ask questions of privacy experts from OpenMined community. My name is Amel Sellami, and I'll be your host for the day. But first, let's introduce our guest, Patrick. Welcome, Patrick. Patrick
Hi.
is Hi. Patrick is the team lead of the Federated Learning team at OpenMined, which is responsible for creating worker libraries in various languages as well as maintaining the PyGrid project. He's been a part of the OpenMined since day one. He created the website blog and the first two versions of the Cypress.js worker library. He primarily worked as a project manager and also lead the web and mobile team at the OpenMined. The web and mobile team is currently around like 8 to 12 people, and they work on a variety of projects, including implementing federated learning for web browsers and mobile phones, as well as other UI-based projects for OpenMined. Thank you for accepting of being with us, Patrick.
Yeah, happy to be here.
Cool. So this is basically the first AMA for a month series, which is the month of federated learning with an open mind. So our first guest is Patrick, who will talk about more or less federated learning. So Patrick, you're free to go.
Yeah,
And
thanks.
before that, please make sure to ask your questions and put them in the comment below so that we can ask them later for Patrick. Thank you.
Awesome. Thanks, Amel. So my name is Patrick. I do lead the Federated Learning team, which has 3 teams underneath it currently. The Grid project, the Grid team, which is formerly known as the PyGrid team. Everyone probably knows that. Basically, SIFT.js running in a cloud environment or in a Docker environment or some sort of remote context. Or excuse me, not SIFT.js, but PySIFT. I also have the workers team in the Federated Learning team, and they are basically responsible for developing SIFT.js, Kotlin SIFT, and SwiftSIFT, as well as Python Federated Learning worker library as well inside of PySIFT. And then we also have a newly created team called the RecSys team, persistent team, that looks to a library for private recommender systems here in the next couple months. So I think actually we can say in a couple weeks, you guys are a couple days, you guys are going to actually hear from the other members of my team who were responsible for building the majority of those libraries, and they'll actually be giving demos. So I won't give a demo today, but I just wanted to give kind of an overview of what Federated Learning is. So I think I can share my screen.
Cool.
Yeah. Great. Okay. Are we good? Can everyone see this?
Yes.
Awesome. Sweet. Yeah, so today's just an overview of federated learning as it currently stands at OpenMined. It will talk a little bit about the future, but I want to go ahead and start by defining 2 of the ways in which we perform federated learning here at OpenMined. We have slightly different terms for these than you might have seen. In the past, you might have seen us call these dynamic and static. Now we actually call them model-centric and data-centric. So to go over kind of an overview of the differences, you might have also heard data-centric be called cross-silo or distributed learning. So something of that nature. It's quite similar. So to go over model-centric, basically we have the ability to perform both training and inferencing of any PyTorch model on devices, quote, at the edge. So that could be a web browser, a mobile device, something like that. We've created a couple libraries for doing this very thing. In JavaScript and Kotlin, you inside of a web browser through JavaScript, or you can do it in Kotlin and Java inside of an iOS app using Swift. We also have just a Python class that you can use inside of PySIFT itself to also perform federated learning or actually test your models before you deploy them to PyGrid. So there is one extra step for SIFT.js, our JavaScript environment, and basically you need to convert the plan from PyTorch to TensorFlow.js We actually use another library that we've created just for this purpose. We considered using Onyx in the past, if those are models from language to language, but we actually determined we wanted a little bit more of a lightweight result, as well as a library that would work in multiple languages and to be run in multiple environments rather than only compiled in Python. So we actually created 3PO for that very purpose. And I'll talk a little bit later about the future of 3PO as well as how to get helping. So right now we only have cycled federated learning processes for model-centric. So that would be basically in PyGrid, you'll have a model hosted that an edge device can pull down, and it will basically have a cycle that will time out and accept workers to submit diffs to be averaged back into the global model. And it'll basically do that for however long you define. So you can define a start and an end time to your cycle, and it'll basically only do a certain number of cycles. This is actually described in Google's white papers related to federated learning. We're going to be supporting cycleless in the future, to where you could just pull down arbitrary PyTorch code or PySift plans and execute them on an edge device or browser. And then there's data-centric, which is also useful for training and inferencing of models. But the difference is that instead, you're actually hosting inside PyGrid a data set, right? So when we say model-centric and data-centric, really what we're asking is, what is centrally hosted, right? So in the case of model-centric, this is where you would use a library for web and mobile, likely to train, or even IoT using Python to train a model at the edge. So in PyGrid, you would actually host that model there because the data lives on the device. In data-centric, it's the opposite, right? It's still federated learning, but it's the opposite flow. You would actually host data centrally, and then you as a data scientist would bring a model to that data to be trained on those computers. So this is actually a little bit more similar to a traditional machine learning approach, data-centric. So essentially, the data scientist would have the ability to provision some sort of private compute environment and then actually dispatch those computations to PyGrid to be executed. So those of you who have been doing federated learning at OpenMined for a while have probably been more familiar with this approach rather than model-centric, which is a bit newer for us. We're also working on the ability to implement differential privacy into the actual aggregation process to basically add noise to the model before it's returned back to the data scientist as a protection mechanism for that private data being hosted in PyGrid. So real quick, I'll go over a couple tenets of model-centric. Again, talking about our flagship libraries for this, SwiftJS, Kotlin Swift, and SwiftSwift. Some things that all the libraries have in common. Again, as I mentioned, they can all train and inference on PyTorch models on any web browser, Android, or iOS device. The great benefit of model-centric is that training data never actually leaves the device or browser itself, so it stays fully local. We have full support for JWT authentication to prevent against various types of networking attacks like Sybil attacks, man in the middle and such. We also allowed for speed testing if you decide that you want to only allow certain workers that meet a certain networking criteria, right? Like they must have a good and stable internet connection. You can do that. That's really great because it basically ensures that the diffs that you're going to be receiving are going to be done in a timely manner, and you're not going to have a lot of worker drop off to where a worker will start downloading a plan and start and we also support both HTTP and WebSocket protocols, depending on however you want to deploy PyGrid. Speaking specifically to the mobile libraries, Kotlin Swift and SwiftSwift, we have support on both of them for battery charge detection. Often when you're performing model-centric FL, you want to ensure that the phone is plugged in. We also have support for Wi-Fi and metered network detection, so you want to ensure that the phone is on a stable Wi-Fi connection and probably not on a cellular data plan, where that would surprise the device owner at the end of the month with a massive bill for data. So another default. All of this auto, you can modify these or change these as you desire. And then we also have the ability for you to hook in your own sleep and wake cycle detection. So actually have the ability to tell the library when the user is likely to be asleep, and therefore when the training task should kick off. Both Kotlin-Sift and Swift-Sift also support training and inference in both the foreground and in the background. Background support is somewhat limited with iOS, just purely as a function of iOS, Apple's inability to code proper background threading. It's not really anything we can do. It's just kind of a tenet of iOS, but hopefully their background manager improves in future iterations of the operating system. And then lastly, we also have support for multi-threading as well as single threading. So basically how it works, the overview is stuff like this. So you'll start as a data scientist by creating a PyTorch model and then a training plan that will be run on the device. And then you'll also create an averaging plan. For those of you who are not familiar with plans, you can actually run through the Getting Started tutorials. I think number 7 or 8 in PySift actually covers plans. It's basically just a way to zip up any sort of function and allow it to be run by some sort of remote worker, either in another instance of PySift or, of course, on Sift.js, Kotlin-Sift, or Swift-Sift. The training plan, as I mentioned, will be run on the device, and the averaging plan is run on the server. So those of you who are familiar with Google's white paper on federated learning, Fed average is kind of or federated average is kind of the standard averaging plan. We support that. And at some point in the future, we will actually have a couple sort of pre-made averaging plans so that you don't have to specify this in the future. You could just say, oh, I want to use this one. Oh, I want to use that one. So you'll write this all in PySift instead of a notebook. And then at that point, you want to connect to your PyGrid instance and host it. You'll need to define both a server and a client configuration. So your server configuration would include things like how long you want the cycle to be, if you have any minimum or bandwidth requirements or such like that. And the client configuration, and the server config could also include things like how many workers do we need to submit diffs until we run the averaging plan, or what is the minimum amount of workers that we support, what is the maximum, the length of the cycle, how many cycles should be run, etc., as well as the worker selection plan, whether that's a random worker selection or it's actually iterative on a first-come, first-served basis. The client configuration, on the other hand, these are basically a series of parameters that you can pass to the actual client, to Sift.js, Kotlin-Sift, or Swift-Sift. So the client configuration parameters could be standard hyperparameters like your alpha, your learning rate, and such like that. And these are mostly up to you. Your batch size, whatever you'd like, number of epochs. The third step is you actually train your PyTorch model using data on the device or the browser. So this would involve actually writing the implementation code in JavaScript, Kotlin, or Swift in your app, in your web application or mobile application to actually perform the training. Mark, Varun, and Vova will actually be going that in subsequent demos, I think in future AMAs with Amel. So they'll actually be going through how to implement those from a client-side perspective, but also offering demos about how they actually physically work. The fourth step would be reporting the model diff back. So basically, once a worker is finished running that training plan, it will actually generate a diff, basically the differential between the model that was trained and the model that you first received, the original model that you first downloaded as a worker. And that diff basically is what's sent back up to PyGrid for averaging. The reason it's important to actually submit the diff is so that you're not uploading the entire newly generated model. That could be way larger than the diff will actually likely be. So you just report the diff, and that differential calculation is done for you in the library. And then lastly, as a data scientist, again, ideally the process is finished. You can actually go in and retrieve your model from PyGrid, and then you could use it for whatever purposes you desire, either for retraining the model, for inferencing across it, of course, or whatever you'd like. So I've actually created a couple diagrams. I'll just actually leave this slide up for a couple seconds, so those of you who are checking out this video later can read it in more detail. We also have these diagrams. I'll show 2 more later for Data-centric that are located on the PyGrid README itself. So if you miss it here or don't have time to view it live, you can either watch it in the video or just read it in the PyGrid README. So I think that's enough time. So we currently have two examples. We have an MNIST example, and we have what's called a multi-armed bandit or reinforcement learning in the browser example. I'll go through both of these, and they'll actually be demoed for you in subsequent AMAs. The local MNIST example basically demonstrates this training of a sample MNIST data set. So kind of the vanilla, getting started hello world type of example for federated learning.
Yeah.
It's deliverable, so obviously you can expand it from there. But again, as mentioned, in order for SIP.js to properly train a PyTorch planet, it first must use 3PO to convert it. You don't actually have to perform this step yourself. It's done internally within PySip when you build a plan. So don't even worry about it. The demo is available at the various videos on GitHub for SIP.js, for Kotlin Sift, and for Swift Sift. We have it available for all three libraries. And then reinforcement learning in the browser. We thought it would be really cool to give kind of more of like a real life example of how this could be used. I have a background in web development. So for me, I've always kind of wanted this idea of having like an AI powered website to where I can just define a couple of permutations and then just have it go and slowly optimize towards that goal. I'm sure most of you have probably heard of A/B testing, which is basically where you create 2 or more versions of the same website with just subtle modifications. Maybe that's like the title in the top hero section is a slightly changed for 50% of users, and it's different for the other 50%. You could do that, and maybe you could create 3 different things, right? But the downside of A/B testing is that you actually have to deploy them all, see the results, and then you actually have to standardize it and deploy that specific version. What we thought would actually be one step better is kind of like automated A/B testing. We call this AI-powered website layout. So you get to define a goal, like I want to optimize for clicking a sign up button, right, or something like that. And the sign up button could be blue, it could be black, it could be white, it could be on top of a black background, it could be on top of a colored background. Maybe the sign up text says get started, maybe it says sign up here, maybe there's 3 or 4 variations of an icon next to it, maybe there's no icon, whatever. I mean, you can imagine that's a lot of permutations of the exact same website to create. So it would be much better if you could just define these configurations in advance and then define your goal. And we actually created a model. I should say, Maddie Shang, who leads our rec system, our newly created recommender system team. She created this, and it's really awesome. It uses Thompson sampling, statistical algorithms underneath the hood, and it's really neat. It'll actually like slowly deviate your website to the generally preferred user experience. So you don't actually have to select these, like run a test for a certain amount of time and then select for it. It'll actually just automatically optimize for people who view your website. So when you enter a website, you'll actually randomly load one of a variety of configurations. And depending on how well trained that model is that's loading every time you view the website, it'll either show you the preferred experience or it'll show you a random one, given just what random category you fall into. So a certain subset of users will always get a random one, but slowly you'll start to see 60, 70, 80, 90% of users will start to get the kind of optimized preferred experience. And what's really cool about the way that this model was made is that it actually it'll accept input in the future. So if you introduce more configurations later, or if the preferences of your users change over time, the model will actually not have to have the same amount of data it had previously to optimize to that point. It'll actually optimize a lot quicker. So it's not so cached, so to speak. It'll actually be more relevant. So this demo at the moment it's awesome. Yeah, this is such a cool demo. This is currently only available for SIP.js. We didn't end up having time or really kind of a reason to do it in Kotlin Sift or Swift Sift, although that would certainly be something cool we could do in the future. It would be really neat to be able to actually have reinforcement learning inside of apps as well as just the browser. So without having to actually download new versions of the application, your app could actually optimize itself over time. And of course, if you're thinking about iterations of this, you could even have a model that would optimize towards a specific user's preferences. So rather than optimizing, and we didn't do this, but you certainly could, it's possible. You could optimize towards an individual user's preferences or the things that they like, or you could use private social data, and none of that data would ever go into the cloud. It would all be used locally, but you could optimize your application or your website specifically towards the individual user's preferences rather than the preferences of all of the users. So that'd be kind of an extra credit. And we'd love to see some PRs around that. So
yeah, I'm looking forward for these kind of demos for the next week.
Yeah, right? I know, I know. Maddie, I think Maddie's going to give you guys a demo of reinforcement learning in the browser. So that'll be really neat. To talk a little bit about the future of model-centric at OpenMined, we've got a lot of things kind of on our mental roadmap, but we're always welcome to a lot more feedback. Currently, because PySIFT doesn't have any support for protocols, which are basically PySIFT's way of talking about how do you coordinate multiple workers and allow them to compute something together. We would like to support secure MPC as well as secure aggregation protocols in the future. Secure MPC is just where a series of workers could actually compute something without knowing the value of each other's shares. So they actually would be able to run a computation in tandem, and neither of them knows the actual eventual value. And secure aggregation is a little bit different. This would basically be a protection for the workers. So you could actually do, if you do global differential privacy at the model level, this would be local differential privacy at the worker level. So basically what would happen is after the training has happened on a particular worker, like in a web browser or in a mobile app running Kotlin or SwiftSIFT, you could actually then pair up a few of these workers who have finished. And instead of submitting, having each worker submit a diff individually, it would actually have, let's just say 3 or 4 or 5 of those workers communicate to each other, chunk up their model diff, send it to each other, and then they would basically compute a securely aggregated version of it that one of them then is chosen to send it back up to PyGrid. So instead of PyGrid getting 5 different model diffs to average from each of the 5 workers, it would instead just receive 1 model diff, but it would be securely aggregated amongst those 5 workers. And the reason why that would be great is you get all the benefits of the model still averaging according to the input of those 5 workers, but you do it in a way that actually protects the individual data of those workers itself. So it's kind of an extra protection. That's why I kind of call it like local differential privacy for workers. So not quite, but that's the gist. Another thing we would want to add is currently we have a hard dependency on TensorFlow.js. I don't know that PyTorch is working on any ports to JavaScript. Yeah, but it would be quite nice to not have to convert every time, or at least to have some rather intuitive way of converting. So, but it's not that big of a deal. In the meantime, we've got 3PO, which we love, and we would love to have more support for 3PO from our community. Actually, one of the biggest issues that we have of people trying to use SIP.js is the fact that because we have to manually translate commands, not only cross-language from Python to JavaScript, but also cross-framework from PyTorch to TensorFlow.js, it's actually quite difficult, and the majority of the commands don't map up correctly. Even if like, let's just say add function, add in PyTorch is add in TensorFlow.js, right? And in this particular circumstance, the arguments would actually line up identically as well. But there's plenty of functions. I think there's a variety of functions. I don't remember if TensorFlow.js has a linear function, but there's a couple examples where the arguments don't actually line up. Not to mention, JavaScript has no knowledge of keyword arguments or quargs, but Python does. How do you map those, right? So that was how we created 3PO. And the biggest reason why we see plans being run in a web browser through SIP.js fail is because we just can't map everything. In 3PO, we actually have scrapers that go out and will go to the various deep learning frameworks, scrape their documentation, and then do their best to automatically map both the command names as well as the argument order and keyword argument order. But it's not an exact science, and so we have a process of adding manual translations to 3PO. So whenever you don't have a model working in SIP.js, it's probably just because 3PO doesn't have support for that command yet. They're really easy to add. It's 5 lines of code that you can more or less copy and paste into 3PO. We just can't, until we've tried every command in every framework, we just can't possibly know what those mappings are. So we could really use a lot of help from our community in building out 3PO command support. And then, of course, also we want to increase the number of frameworks. Right now, we have really solid support, I think we do, for PyTorch and TensorFlow.js, as well as TensorFlow in Python to some degree. We'd love to add other deep learning frameworks, such as Keras or NumPy or such like that. So we'd love to add more framework support. We'd also love the ability to execute PyTorch and PySift plans regardless of the cycle. So as I mentioned earlier, in the future, we hope to support cycled and cycle-less model-centric execution. But right now, you can just execute within a cycle. Workers actually will have to be accepted or rejected into a cycle. If they're rejected, they can try after a certain amount of time. PyGrid will say, hey, come back to me in 3 hours and 27 seconds, and I'll let you try again to apply for that cycle if there's another one. But if you're accepted, you can execution of plans to where any worker can just arbitrarily request whenever the user desires or whenever the developer configures the script to be run to actually pull down a plan and a model and train against those. Just arbitrary of any cycle. This is not how Google does federated learning. Again, they have a cycled approach, but it'd be really neat to be able to support both. And then lastly, this is kind of a stretch goal for us. Right now, we actually only have the ability for the worker to initiate the flow. So SIFT.js, Kotlin-Sift, and SwiftSift actually have to initiate the pulling process from PyGrid. We would love to allow PyGrid to have PubSub support, where you can actually push those models and those plans to workers and have them execute if the worker agrees to that. So rather than a worker pulling, whenever the user or the developer defines, the web or mobile developer defines to be a good time to do that, it'd be really great for the data scientists to actually be able to say, hey, all of my workers that are currently connected to PyGrid, run this plan on this model and do it. So eventually do that via some sort of PubSub support.
Cool.
So
lots to be done.
that's a lot. We're about halfway there. Amel, am I good on? Are we good? I don't know how long.
Yes.
Yeah, awesome.
Yes.
Sweet.
For 30 minutes.
Awesome. Okay, great.
Cool.
So now I'll go through a little bit of data-centric. This is actually shifting over a little bit more to the work of the grid team than the workers team. So data-centric FL is probably a lot more familiar to the average data scientist than model-centric. And I'll go through a couple different approaches. Right now, those of you who have been trying out PyGrid might have noticed that we've had a lot of breaking changes lately and a lot of renaming of API endpoints and a lot of renaming of classes for our workers and our clients. Sorry about that. It's in the best interest of our future, but I think you'll be happy with the changes in the long run. We're actually hoping to build out a wide variety of additional cool things for PyGrid. You should expect to see a lot of development on the PyGrid project over the next 5 to 6 months. A lot of this work is actually being sponsored from the University of California in San Francisco, UCSF. They actually sponsored a grant with OpenMined for a series of a couple of developers who were chosen recently. I actually managed that project as well as co-managed the grid team with Ionisio. But the UCSF grant actually has paid a couple members to join the grid team and to actually make a series of increases. So again, over the next 5 to 6 months, expect to see a really concerted effort to develop PyGrid and really stabilize it quite a lot. So there's 2 approaches that we talked about in data-centric FL. The first is a node-based approach. You could think of a node as basically just a place to host data, right? Again, data-centric, you host data in the PyGrid node. The node is kind of the main project for PyGrid. If you're doing a model-centric approach, you would host a model on your node. It's the same type of thing. Those of you who have used PyGrid in the past might be familiar with the concept of workers, running a worker inside of a node. We're actually moving towards a system to where nodes will kind of act as a load balancer for workers. So rather than spinning up a worker in like a virtual worker inside of a node itself, a worker likely going to be a separate machine entirely. So if you're a data scientist, you would have the ability to go in and environment, basically provision a worker that is actually deployed to some other machine, like a EC2 instance on Amazon Web Services or something like that. You get to specify the hardware that you like, and that's kind of like your dedicated data science environment, right? But it's all controlled by the node. So basically, you would access it from there, and then the node will divvy out the instructions, send the instructions to the appropriate worker. So that's kind of an abstraction that we're creating. But more or less, a node you can think of as a central location for any person or organization to host private data. So this allows workers to be created. Again, workers are moving away from being virtual workers on the same machine as the node, and actually moving towards being individual servers that can be spun up separate from the node. And these are purely just computation servers. So they actually don't, they actually won't host any data. The database will actually be centrally located with the node, and there will be one database, right? So rather than having each node, or excuse me, each worker have its own database, instead the node will hold all of the data for that organization or that person hosting the node, and then the worker will basically be sent the data as well as the request from the data scientist as well as the model to train the model with the plan using the data. The node is a central database. Excuse me. The central database, as I mentioned, is connected to the node, and then the training and inference requests are actually delegated to a specific worker. And we have a pretty simple search and discovery API right now. We're looking to expand this. Currently, you can only search across tags on tensors or such like that. We're hoping to provide abstractions, a top-level abstraction on top of tensors called dataset, which will essentially handle any sort of metadata and then have a collection of tensors underneath it. So you could actually label a tensor as your training data tensor, or your testing data tensor, or something like that to separate those out. Network is actually a step above. So if your node is basically where your data lives, a network is a way to connect multiple nodes together. So essentially, it's the exact same setup, but if you're in the discovery process, you likely don't know where the data that you're looking for is going to be hosted. So let's say that I'm a data scientist and I want to search for all data sets related to diabetes, right? If I know, or if I have a specific arrangement with a hospital that's running a PyGrid node, I could actually specifically say, hey, UCSF, for instance, or Vanderbilt Hospital, whomever. I want this diabetes data set. I want to train on this information, et cetera, send the request, go. But if you're discovering and trying to figure out where data could possibly exist, it may exist, let's just say, or it may be more easily searchable through a network. So let's just say a network could be actually like a series of hospitals that are linked together, to use that analogy. So potentially the University of California has a variety of hospitals, and one node would be the San Francisco hospital, another would be the Los Angeles hospital, et cetera, right? And those could be a network. Yeah. On the other hand, you might have a network be a higher level of abstraction on top of that. You could have a network that would be, for instance, the US Department of Health or the Center for Disease Control could run a network. And that would then connect to UCSF, UCLA, Vanderbilt, Mount Sinai, et cetera, all the hospitals in the country. And so that way you could actually query the US Department of Health's network, and you could search, virtually all the hospitals in the country who are running nodes. You could search all of their nodes for the same tag, all at the same time, and then receive your results back in a synchronous manner. So that's kind of the purpose of a network, to clear that up. So it's the same, it allows the same functionality as a node. It's just an abstraction above that allows you to search multiple nodes simultaneously. It doesn't have any particular way in which it forces these nodes to be configured within the network, it's totally up to the network operator. So yeah, so how it works, as I mentioned, you'll start by searching for a data set that you'd like to work with. You can then create a training plan or set of operations that you'd like to execute. You would then send your instructions, your data request with the specific data that you would like, or the tensors that you would like to operate against, and your model, whether it's been pre-trained or whether it's blank and zeroed out, and you send that to the PyGrid node of your choosing. Execution is then done by a PyGrid worker. At this point, you will have said, hey, node, I would like for you to configure a worker with 2 GPUs and this much RAM and so on and so forth. We're working on this functionality. It doesn't currently exist, but in the future, you'll be able to do that. And I'll talk about that a little in the future slide later. There's an optional step. If you're a node owner and you have someone, we call this type of user a data compliance officer, right? So this person could basically be responsible for triaging models that have been trained on workers on your infrastructure in your PyGrid system. And then before sending them back to the data scientists, you could either approve them or deny them according to a privacy budget. So we're working with the awesome differential privacy team at OpenMined to make this possible. Essentially, the data compliance officer would log in to the PyGrid node, and they would be able to see all outstanding model release requests. So these models have been trained or the result of some sort of inference, and they would actually be able to look at the result and determine whether or not there is too much privacy leakage in the training of that model, at which point they could then go back to the data scientist and say, hey, I'd like for you to modify in this way, or submit with this differential privacy, epsilon, et cetera, to where there would be less data leakage inside of the model itself that could be out later. Obviously, the last thing that you want to do, particularly in sensitive data environments, is leak sensitive information like patient records or government records or such like that, census information. So this is an optional step, but it's up to you as the PyGrid node owner to decide if you agree to approve them all or triage them accordingly. And then last, as I mentioned, you just want to release the trained model or inference result back to you, the data scientist. So that is roughly how it works. As I did before, I'll actually leave 2 slides up. This is the node-only workflow. So you can see the data scientist here at the top, makes a request to the node. That will then get the appropriate data, return it back to the node, send it to the appropriate worker that the data scientist also requested. The computation happens on the worker. The result is sent back to the node, and then it's eventually sent back to the data scientist. If you're operating in the form of a network,
Okay, I think Patrick just logged off, so I think there is a technical problem with him. We'll be waiting for him to join again. Okay, he's back.
Amel, I left.
Hey.
I don't know what happened.
Yeah, no problem. If you want, you just eat.
I'll pick up where I left off. Yeah,
probably.
sorry. I heard my headset go blank and I couldn't hear anything. I was very confused. Like, wow, okay. Yeah, let me go ahead and share my screen again. See if I can get this working. Do you remember where I cut out specifically?
Yes, you was talking about the.
So the node. I'll start from the node-only workflow. So sorry about that, guys. I'm going ahead and sharing my screen. I'm on the Data-centric FL node-only workflow slide. And I'll also be sure to share these slides in after the AMA, so you all can find them and look at them. So going over the node again, my apologies. I don't know where I cut out, so I'll just go over this again. Basically, the data scientist would send the request for data, as well as their model and their training plan to the node. It would retrieve that data from the database, send it back to the node. It would provision the appropriate worker that the data scientist requested. The training would happen on the worker. The training would then be sent back to the node, and then, assuming it's approved, would be sent back to the data scientist. So that's the node-only workflow. And then we basically have the same type of thing for the network. The only difference is that the data scientist would actually submit his or her request to the network before those would actually be sent to the appropriate node. So it's basically the same thing. Yeah, but just done through a network. So you can see here, this cluster right here could be hospital 1, this one could be hospital 2, and this could be hospital 3. Or maybe these are divisions of the government, like the Department of Defense, the IRS, whatever you'd like. So, Amel, can you guys still hear me and see my screen? Is everything good?
Yes. Yes,
awesome.
Everything
Great.
is good. Thank you.
Awesome. Yeah. So last
we'll
couple
be
slides.
sharing the slides.
Yes, I will. I'll
Okay.
send you all a link to the slides after this. And actually, I think Madeline, if he's on this call, he can drop the link in the chat. That's perfectly fine too.
Yes.
So the future. So what does the PyGrid project want to do in the future for Data-centric FL? Long story short, we want to do a lot. We want to add support for differential privacy budgeting that will allow node owners to be able to apply global differential privacy on top of data that's been computed at the worker, as well as the ability to approve or deny approve or deny the resulting model or the resulting inference back to the data scientist before it just goes straight to them. So we also want the ability to triage training and inference release requests, as I mentioned. A big one for us, we're actually working on deployment of PyGrid to all major cloud providers. So those of you who have been working with PyGrid at the moment know that it currently just works with Docker, as well as the ability to just run the process directly. You will still have the ability to do this, so you could still run the process directly if you want to SSH into the shell of some sort of server that you have running, and then run the process there. Or you could actually spin it up using your own custom Docker Compose. In the PyGrid project, we actually already have a standard Docker Compose that you can use. I think it spins up 1 node and 4 workers appropriately. I don't know if it spins up a network. I don't recall. But you can basically modify that Docker Compose to your needs. But we'll also actually add the ability to support deployment to Amazon Web Services, Google Cloud Platform, and Azure Cloud as well as other cloud providers. And the coolest part about this is that we'll actually be able to do it in a variety of ways, including the ability to write it via code. You could actually write code as infrastructure using Terraform. We're going to open up support for that, as well as the ability to do it via CLI. We're going to create a command line interface for PyGrid at some point where you could deploy it that way. Something like a PyGrid deploy in your terminal. And then we're also going to allow one more way to deploy to the cloud, which I'll talk about momentarily. We also want to add support for both server full and serverless deployment. This one is a bit confusing, but basically if you want, particularly to just do model-centric, so training on devices or web browsers, it's more likely that you would just need to run a single node, right? You wouldn't run any workers and you wouldn't run a network. But the great thing about it is that we've built PyGrid in a way to where you could either deploy this as an instance, a server full instance that's running on a computer 24/7, it never goes down, right? Alternatively, you could run it as a Lambda function. So actually it's a serverless Lambda function running in AWS, GCP, or Azure. So that's going to be really cool, the ability to deploy both nodes and networks as serverless functions rather than as server full deployments. That should save you a ton on monthly costs. Anyone who's run EC2 instances on AWS knows how expensive it can get, and particularly scaling.
Yeah.
So serverless, it takes it down from dozens or hundreds of dollars a month to literally either free or pennies a month. So it'll be a big deal. Yeah, workers, just because of the nature of what they are, will never be able to be serverless. Those will always have to be a server full deployment or a running instance. basically because you want to specify compute details. So, I want 2 GPUs, and I want, because I'm super rich, I want a bunch of Titan RTXs, something like that, right? Just kidding. So you could specify that if you wanted, but you can't really do that with serverless deployment. You can only do it with an EC2 instance or the equivalent on GCP or Azure. And then also, we actually want to integrate billing directly into PyGrid. This is a recent feature that's in the process of being added to our roadmap. We haven't fleshed this out fully, but we actually want the ability to be able to charge people according to the environments that they spin up. So if you're a node owner and you have data that you want to open source and be able to publicize without actually releasing the data set itself, which could compromise the privacy of the data or the integrity of it, you should be able to basically not have to pay for all of the cloud environments that the data scientists that train or inference across your data have to spin up in order to do their work. So if you're a data scientist, think of this as no different than renting a VM through some sort of like GPU provider. I think there's a couple of companies that do this. I think there's like one called Liquid or something like that, where you could basically like rent a GPU, and it kind of gives you like a Linux environment or something like that. We'll pretty much do the exact same thing, but you would actually have access. You would have the ability to run Python notebooks on this type of environment, and it's however you specify. But the difference is that you would be able to supply either a bank account or a credit card or a debit card or something like that, and it would actually bill you specifically for that, rather than the owner of the PyGrid node having to be responsible for paying for all the infrastructure, and then maybe there's a contract that's negotiated outside, and that's just a mess. We want to be able to support billing internally to PyGrid, and even have the ability to actually add on. A lot of these PyGrid node owners will want to make a business out of opening up their data sets. I don't think that's terribly unreasonable if they not only want to make their money back, but they want to maybe make a little money on top. Yeah, they're providing a service. So they should actually be able to specify, oh, I want to tack on 5% or 10% or however much they specify for the use of their services and the use of their data sets. So I almost forgot. One of the biggest things that the PyGrid project is working on is an actual user interface. We're going to call this PyGrid admin. And this is honestly, as a web developer, this is one of the things I'm most excited for. This will be a central user interface that you can have, totally open source, that will allow you to manage both the model-centric and the data-centric FL processes, all from one location. So if you're running data-centric and you want to manage your data sets, you won't have to do this in a terminal or in a Python notebook to actually host a data set anymore. You'll actually be able to just upload a data set straight right there in the browser. And it'll upload to your PyGrid node and be accessible to data scientists right there. Tag it, write metadata, describe the schema, etc. Tag your tensors, whatever. For model-centric, you'll be able to do pretty much the same thing. You'll be able to specify the contents of your model. You'll be able to watch the process, see how many workers are currently working on the active cycle. You'll be able to view statistics about how it's going, as well as see the accuracy and the loss increasing and decreasing respectively, literally live in real time as the training is going on the devices, as the diffs are being submitted. So that's going to be really cool. You'll also have the ability to manage all of your infrastructure from this. So in addition to managing your node or your network from PyGrid admin, you'll actually be able to specify scaling, whether that's manual scaling or auto scaling. If you want to add more instances of the same PyGrid node, perhaps you're running a WebSocket connection, which your PyGrid node can only handle a certain amount of. You'll be able to actually horizontally scale those, or as well as vertically scale those. If you want to not allow for data scientists to be able to spin up environments of their specification, you could actually have preset workers that are always there and sitting and waiting for instructions, and it would go into a job queue, and you can actually manage how many workers you have, and as well as the sizes of them or such like that. and you can actually control all of the deployment specifications right here inside of PyGrid admin. You'll, as I mentioned, be able to access the resources and data sets that you specify, and then you'll also be able to manage your billing and usage, as well as track revenue and expenses and such like that. So this is something we're really excited about. This screenshot right here you see on the left is totally pro forma. We're developing this, kind of building the plane as we're flying it, so to speak. And this UI will get a little bit more fleshed out. You can see there's a couple things in here where we reference dynamic and static. That'll change to model-centric and model-centric and data-centric and model-centric respectively. But we're updating this UI as things come along, as well as how PySift develops over the next few releases. So that's it for me. If you'd like support on any of this, or if you want to discuss it with myself or anyone else on the team, we're always happy to discuss or answer any questions. And if you're looking to contribute, we actually have, I think on the SIFT.js, Kotlin SIFT, Swift SIFT, and 3PO libraries, I think we have over 100 to 120 good first issues that are available. They're legitimate beginner issues. I'm not a data scientist. I could do these. So really, you don't need any special experience in PyGrid or PySift or data science or anything like that. A lot of them are just specific to documenting individual files or testing individual files. We have a couple people working on these, but we need all the help we can get. I know in particular, we don't have a lot of JavaScript or Kotlin or Swift developers coming into our community. So if that is, if those are languages you're comfortable with, please send me a DM on Slack. We'd love to hear from you. You can join any of these channels. Likewise, you can apply to join our team at placements.openmind.org, and you can find me on Slack or on GitHub at Serial Larcening. And I think that's it for me. Amel.
I really do encourage people to join, because this is really going to be something awesome. Yeah, lots of people loved it. But cool. So basically right now I'm just going for a couple of minutes for the questions. And we're starting with the first one, which is OpenMined does OpenMined support mobile app with federated learning? So yes.
Yes. Yeah. So you can use Kotlin SIFT and Swift SIFT to do that. That would be that would be through a model-centric flow. If you're looking for more documentation on how to do model-centric, you can either go directly to the Kotlin SIFT or Swift SIFT libraries. The READMEs are really thorough, I think, at this point. You can also go to the PyGrid repo, and there's actually a whole section on model-centric, as well as how to configure that and get that going from the server standpoint. Kotlin SIFT and Swift SIFT would be from the client standpoint, as well as SIFT.js for web. So
cool, thank you. Another question is it possible to switch between aggregating parameters and averaging them? Is one more favorable than the others?
I think I understand the question. If you're talking about kind of how the averaging plan works on PyGrid for model-centric, yes, that would be totally possible. You just specify that in your plan. So you'll have to write a function that actually runs your averaging plan itself, whether that's fed average from Google or something like that, and you can modify the parameters as you desire. I hope that answers that question. I'm not sure.
Yes, cool, thank you. Okay, another question is, when averaging the model, on the server, do we need to do anything to the optimizer, since each model requires a specific optimizer for it?
Good question. I don't believe so, because that would actually be specified in your averaging plan itself. So it just entirely depends on how the average plan is set up. But we've got documentation on both sample training plans as well as simple averaging plans that you can pretty much copy and paste into your PyGrid deployment. One thing I would say is that all three libraries, SIFT.js, Kotlin SIFT, and Swift SIFT, support multiple plans to be run. So if you have a training plan, maybe you have two training plans for some reason, or if you have one to run on, if 50% of your users do this and the other for this 50%, you can define multiple plans. So it doesn't really matter. yeah, you can have multiple training plans for the client, and you just submit one averaging plan for the server. Yeah.
Cool. Okay, here is a personal question, I think. What's your single favorite OpenMined library and why?
That's a really tough question.
Yeah.
I'm a little bit biased because I have a few libraries that I'm either the only contributor to that I've written myself, or I'm one of two contributors or three contributors. Sif.js is one of those. I'm actually working with Ericles Emmanuel from the Grid team on OpenMined UI. He's doing an awesome job on helping us develop a UI library to where in the future people will actually be able to build user interfaces at OpenMined, and it'll actually follow the brand guide and the brand samples and have a variety of React components specifically developed by the design team, by Bennett Farkas and Kyoko Eng from the design team.
Yeah.
They are ridiculously talented. And so, yeah, so I'm a little bit biased to like OMUI or Sif.js, but I have a soft spot for PyGrid. I don't have nearly as much Python experience as I do JavaScript, so it's hard to say. I think in terms of Python, my favorite library is PyGrid, though. A little biased.
Yeah.
So, good question.
Biased, yes. Good question. Exactly. Okay, another question is, sorry if I missed that, but how does the worker access the data on the node? Thanks. That's over.
Yeah, so how does the worker access data on the node? I guess if that's referring to data-centric, so basically what would happen is if you're a data scientist, you would specify, first of all, you've already searched for the data set that you like to be, or the tensors that you'd like to be working with. And you maybe if they're public or private, you've had to make a request for permissions to access them or something like that. The node owner would have to approve. But basically you would specify in the PyGrid node, you would specify what tensors you want to operate off of. You would specify the operations that you'd like to run against those tensors, or the plan, or something like that. However you choose to actually perform that execution, and then basically, and then you would also supply your model, whether that's pre-trained or it's zeroed out or something like that. You send all that data to the node, and then basically the PyGrid node would go to the database, get the data that you requested, right, and actually send it directly to the worker. So the worker, you wouldn't actually be talking to directly. You would do all communication through the node. That is actually a pretty big change in the way that PyGrid is structured. And the reason for that change is purely just because of infrastructure requirements. We can actually deploy nodes as a serverless environment that allows you to save a ton of money, rather than having a node as a server and then a bunch of workers as servers as well, which could get quite expensive. So we did that separation deliberately to where the node is the only component in PyGrid that actually handles data, and it just sends it to the worker, and it's ephemeral. So as soon as the worker's done with it, it just removes it from its in-memory database, and it doesn't see it again. So
cool. Thank you. Okay, another question is, will the nodes have unique workers, or could they have some overlapping in sharing workers?
Great question. We're trying to figure this out. I think I'm kind of the opinion I spoke to Andrew Trask about this, who leads the community and of course the PySif project. But in speaking to him about it, he seems, I think, particularly interested in allowing data scientists to specify the type of environment and the type of hardware that they would like, particularly when you get into enterprise environments where, like at major companies where like money is no object and you could train like a $12 million model or something like that, right? You're really going to be able to want to have full control over what workers are spun up. But as a node owner, you don't necessarily want to be responsible for running like a 6 GPU Titan RTX card setup. I mean, that's super expensive, and running it 24 hours a day for like weeks, right? Wow. You want to definitely, you know what I mean? Like, yeah, like you want to be able to bill your data science customers for that. So it's kind of this argument of, should we allow the data scientists to be able to provision their own environment according to however they specify? Or should the PyGrid node owner actually be responsible for specifying, these are my workers, take it or leave it, this is how much you get, and submit your job, it'll go into a queue, and the workers will get to it when, whenever they have time, or if there's a free one, we'll get to it around now. We'll get around to it now. So we're trying to figure that out. It's likely that we'll support both workflows, but that's a pretty increased development complexity, I think. So trying to determine which one is more valuable. So we'd love some community input. If you guys would like, if you would prefer to specify the hardware of your environment, or if you would prefer to allow the node owner to specify that. I suppose it's biased depending on who you are, a data scientist or a node owner. So depending on who you are, you might want different things. So
yeah, exactly. Okay, there is a request though.
Awesome.
If it's possible, would you please share the link for the averaging plans? I'm not sure what does that mean.
Yeah. We can. I can share. Actually, you can find them in SIFT.js, Kotlin Sift, and Swift Sift. We actually have links to the PySift repo that contains notebooks for actually generating the model or the plan or the training plan or the averaging plan, such like that. And all of that is contained within those notebooks, and you can find them pretty easily from all of the worker library repos. I think you can also find that from the PyGrid repo in the Model-centric section. So yeah, that should get it to you.
Cool, thank you. Another question, and I think this is the last. Would you extend your library support for other programming languages like Java or Go for production systems for PySift or PyGrid?
Heck yeah, we would. Yeah, there's talk. I don't know enough right now, but there's talk of trying to actually abstract Sift into like a lower level language, and then generating various forms of Sift, like in Python or in Go or Java or Kotlin or Swift even, or JavaScript. So and then just basically having different languages as different compilation environments or something like that. So yes, I think this is in our 6 month to a year long vision, although I gotta admit I don't know a ton about that. Right now we don't have a worker library specifically for Go or in Java. I don't recall, but I believe Java would actually have the ability to execute Kotlin if it's in an Android environment. I'm not sure. I could be wrong. Not a Kotlin developer, so forgive me. But so for Java, you may actually have that. You may actually have that accessible already in Java. I think Varun Kare, who leads the Kotlin Sift project, is actually here, and maybe he can talk on that more, or you guys can DM him in Slack. As for Go, we'd love to support it. We don't have any current plans to, but Tushar, if you're a Go developer, should send me a message. We could be friends. I think it'd be great.
Yeah, cool.
I think there's one more question
now. Yes. Okay. Is it possible to simulate federated learning over wireless networks using PySift?
Yeah, absolutely. So by wireless network, I guess the answer to this question probably means like a local host environment. So maybe you're on one computer and then you have like a Raspberry Pi in a different environment. By the way, Varun just replied back and said Java and Kotlin work hand in hand. So there'd be no need for a Java worker library. You would just need Go, because we don't support that. But Kotlin would support Java. Sorry, back to the other question. Yes, you totally could support training over like a LAN network or something like that. Yeah, that's totally doable. I think actually the notebooks that we have use the PySift Federated Learning Worker, which is more or less identical to what SIFT.js, Kotlin Sift, and Swift Sift are doing, just in Python, and actually uses PySift as the execution language rather than having to make those for each of those other languages. So I believe when you're testing out your training plan before deploying it to PyGrid, you can use the PySift Federated Learning Worker to actually test that. And the same concept would apply if you want to have a PySift worker on an IoT device or on another computer running in the same local area network, and then have PyGrid also located on a different computer hosting the model. So yes, that should totally be possible.
Cool, great, thank you. Okay, I think with this question, this is the last part of the AMA.
Awesome.
Thank you very much, Patrick, for being our guest today. And
Yeah,
as we said,
you.
this is the first AMA of the series for this month, which is dedicated to federated learning. So I hope you enjoy your weekend, and we'll see you probably next Tuesday, hopefully. So
Make sure to tune into that. Yeah, make sure to tune in, because I'm sure you guys were got bored of my slide deck. It was purely informational today, but in the future, in the next demos, you'll actually see in the next AMAs, you'll see demos of everything I just described today. It should be super awesome. So check those out.
Yes, thank you very much. Bye bye,
Awesome.
everyone.
Thanks. Bye.